at this point we need to stop and we need to learn how to make equivalent fractions for further study of fractions. And this is going to combine a couple of things that you've already learned. It's going to combine multiplying fractions, which probably you found to be fairly easy, and as long as you memorize your multiples or you can look them up quickly, not that difficult. And it's also going to use the fact that we had a fractional representation of 1, like 2 over 2. Any fraction over itself, like 2 over 2 is 1, 4 over 4 is 1. So we're going to use fraction equivalents of 1 in this lesson 2 to develop fractions that are equivalent. Now when we get to a place where we're adding and subtracting fractions whose denominators are not the same, we're going to use this skill, which combines a lot of things. So let's just practice this skill isolated really quick. It won't take you long to learn this. It's not that bad. So I'm going to start with a simple fraction again. We always start with something simple so you understand the process, and then we can do much more complex things once you understand the process. So let's just draw a model of 1/2. You're going to see the familiar Kit Kat bar model come up in just a second. So that's our fraction 1/2, and we know that this segment colored in actually equals that. We could have colored in the other segment too. Either one of these would represent that 1/2 for us. Now let's just look at what happens when we divide this model, which is in halves now. If we divide it into 4 pieces like a Kit Kat bar, so I'm going to draw a line there, and we now have 1, 2, 3, 4 equal parts, so it's in fourths now. Now let's look at the fraction and see what it becomes. It's now 1, 2, I'm going to draw an equal sign here, 1, 2 over 1, 2, 3, 4. So it's now 2 out of 4. But what you'll notice is we didn't change the size of the whole. We also didn't change the size of the initial part. The initial 1/2 is still the same size as the new 2/4. The whole didn't change either. We did not change the dynamic or the dimension of that fraction in any way. That's why it's an equivalent fraction. It is the exact same, but notice it just looks a little bit different. You might, if I was to compare these and I were to ask you which one's bigger, you might say, well, that one's bigger. And that's not a terrible answer because the numbers are bigger, so it's an automatic response, but hopefully you see here that the correct answer is neither of them are bigger. They're both exactly the same. Now let's extend this just a little bit further. Let's take it to see if we can make another equivalent fraction. If I divide these yet again, now I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. So it's how many out of 8 in my fractional part is 1, 2, 3, 4. So it's now 4 out of 8. Again, didn't change the dimension of the whole, didn't change the dimension of the part, I just segmented it differently. So the count of segments is more for this fraction, but those 3 are all exactly the same fraction. That's a modeling of it. We may have you model a couple of these. We'll see, but let me show you the algorithm for this. We know it works. We've seen it. We know. We just proved that 1/2. We're going to start with this one. We proved that 1/2 equals 2/4. Let's look at the algorithm for doing this. If I wanted to do this quickly, how can I create an equivalent fraction? So I want to turn 1/2 into something that looks like that. And I'm going to multiply it by another fraction in order to do that. And I need my denominator, because this is usually the case, is I need to make a denominator match. So I'm usually looking at the denominator to determine what I need to turn this fraction to. And I need the denominator to be 2. So I'm going to multiply by 2. Now, when I multiply that by 2, I'm going to multiply the top and bottom by 2. This is the formula for finding an equivalent fraction. So see what happens. 2 times 2 is 4. 1 times 2 is now 2, and I have that 2/4 fraction. Here's the thing I want you to notice here. We should recognize this as being 1. That's the fractional equivalence of 1. We should know that when we multiply anything by 1, it becomes itself. Even though the fraction looks different, we've already established that it's equivalent, it's the same fraction. But I multiplied by 1 to get it there, and that really just proves that I didn't change anything. It's the same fraction still because I multiplied it by 1. So you always multiply by this fractional equivalence of 1. Now, this might still be a tiny bit confusing. It will become easier as you practice. What we're going to have you do in this practice set is this. I'm going to say, let's take the fraction, let's do a little bit more complicated fraction, 2/3. And I want to find the equivalent fraction that has a denominator of 6 because eventually I'm going to need to use a fraction that has that denominator in order to complete an operation. You'll understand that soon enough. So I want to multiply this by the fractional equivalent of 1, because again, I can't change it. I'm not changing the dimension of the fraction. Of the whole, I'm not changing the dimension of the part. I'm just changing the way it looks. The numbers are going to look bigger, but it's not going to actually be a bigger space that it occupies. So I ask myself 3 to 6, so 3 times 2 is 6. So I'm going to multiply the top by 2 also so that I have that fraction of 1. When I'm finding equivalent fractions, I have to multiply, or, which we'll learn in a minute, divide by 1. So then I multiply 2 times 2, which gives me 4. So the equivalent fraction is 4 out of 6. Let's do one more. Then I'm going to turn it over to you to do some practice with some more simple fractions. Then we'll have a lesson where you do practice with some more complex fractions. So let's do 3/5 this time. I know I'm going to multiply it by something equivalent of 1, and I need a fraction now that has a denominator of 20. And you'll see why these decisions I'm giving you now, eventually they'll be determined for you. This skill has a lot of application, actually, you'll find. So I ask myself, how do I get from 5 to 20? Well, I multiply 5 times 4. That gets me to 20. So I have to multiply the top by 4 also. I have to have that equivalent fraction. That fraction has to be 1 in order to create an fraction that's equal to it, because times 1 doesn't change it. 3 times 4 is 12. So see, I'm multiplying, just applying the rule of multiplication of fractions. So my equivalent fraction is 12 over 20 now. Again, just to review, this fraction and this fraction are the same. They represent the same amount of space, the same size of a whole, the same size of a part. I've just made the numbers a little bit bigger, and it's going to fulfill a purpose for us later. So good luck with this practice. Ask lots of questions if you need to.